This video will walk you through and try to explain recursion in a simple way as possible. So recursion is just a way to repeat something a certain number of times. Just like we did with loops for int I is equal to 0, I is less than 3, I plus plus. If I wanted to, I can save this and then I can do the same thing with a while loop. I is equal to 0 while I is less than 3, and then I'll put a while in there to differentiate, and then I'll have an I plus plus. So this is just two ways to repeat things in Java. One is a for loop, the other one is a while loop. Now there's another way to repeat, and that is using recursion. So how are we going to do that? Well, the first thing I'm going to do is I'm going to make a static method named recurse. And the reason it's static is so that I can just call it like so. So I'm just going to go in there and add a little n equals n. And then I'm going to call this from here, recurse, with the value of 3, save it, compile, and run again, and okay. So I can just simply call the method like so, because I made it static, sending the value of 3, and you can see that it shows. Now, what I'm going to do is I'm going to add a couple of things. I'm not going to just leave this, I'm going to leave this system on print line, but I'm also going to have an if, and I'm going to say if my value of n is equal to 1, I'm just going to say return. And otherwise, I'm going to say else, I'm going to tell it call yourself with n minus 1. So I'm telling the function recurse to call its own self so that it jumps back into its own self, basically. That is the recursion. So how is it going to work? I'm going to send the value 3, n is going to be equal to 3. We're going to show n is equal to 3. We're going to check to see if n is equal to 1. N is not equal to 1 since it's 3. Then we're going to go to the else, and we're going to make it call itself with 3 minus 1. Then the function is going to call itself now with 2. We're going to show the 2. This is not going to be equal to 1, so we're going to call it, we're going to make it call itself one more time. This time it's going to be with 2 minus 1. So 1, we're going to show the 1, and then as soon as n is equal to 1, we're just going to say return, meaning that the function is not going to call itself anymore. So it's a way to make the function call itself repeatedly a certain number of times, like so, similarly to how we did with a loop. Now, it might be hard to visualize this, and that is the reason I have drawn some pictures here for this example for the recursion in section 6.6. So what you're seeing here is a similar example to what I created for you. So it's a recursive function which calls itself repeatedly, right, until certain final condition is met, and then it just stops calling itself. It returns a value. So the only difference is this one is an int, so it returns a value, and ours was a void, so it did not return a value. Okay, so now we're going to call the function factorial with a value of 3, similarly to how I called it here in the main. And we're going to trace the steps. We're going to jump into the function as it calls itself. So originally, it calls itself with, we're calling the function right here, and we're calling it with the value of 3. So that means n is equal to 3 here from this value. So we're going to look at this function. Imagine the function called for the first time, but this time is with value of 3. N is 3. Is n equal to 1? Nope. We're going to go to the else, and we're going to jump. The next thing we need to do is now we're going to jump into another function call of the factorial, which is its own self. So now we're calling it, telling it to call itself with 3 minus 1. That was the value of n. So now we'll call itself with 2. And again, 2 is not equal to 1, so we'll go to the else. So we'll have to call itself one more time, this time with 2 minus 1. So this time the n is 1. When the n is 1, it will stop calling itself. This is where it stops calling itself, and it tells to return n, which is just 1. So as soon as we get to this return here, now the function will have to return to where it was called, which is right here. So we have to return back to the origin of the call. So returning back the value of 1 where the function was called. And then the next thing that's left into this function itself now is to return again. So at the end of it, it has to return back to where it was called, which was here. And we're going to return 2 times the value 1. So that's what's being returned here. So this whole thing here, that this function called factorial 3 minus 1 is replaced by the value 2 times 1. So now we have to do another return. When we get to the end of this factorial function, we have to get to this, when we get to this return, now we're returning 3 times 2 times 1, which is what returned from before. So returning 3 times 2 times 1 back to the original code, which is here, and that's where it stops. We're bringing back 3 times 2 times 1, which is just the value 6, and that's what this result variable becomes equal to. So that's a recursion. You need to draw some of these pictures for yourself to visualize it in the beginning in order to wrap your mind about it. But after a while, these drawings are no longer necessary.